In the age of CD changers, MP3 players, and digital television, electronic devices are being equipped with numerous new functions, but users are often overwhelmed. A new form of human-technology interaction is absolutely necessary. This is where the EMBASSI project comes in. A team of engineers, computer scientists, ergonomists, psychologists, and designers are developing the innovative multi-module assistance for infotainment and service infrastructures. The goal is to enable each user to operate everyday technology easily and intuitively. The growing demand for mobility must be taken into account, whether at home, while underway in a car, or during a visit to your bank to take care of banking business. The innovative service assistance should be available at all times. To this end, the researchers are realizing an intelligent environment. The available hardware is organized independently by the system. An avatar assists with communication. The intelligent system recognizes the line of sight, speech, and gestures. These signals are processed and executed according to the desires of the user. The EMBASSI developers thus make humans the center of focus. Individuals no longer perform technical functions, they communicate their goals. EMBASSI consists of an open and expandable network of components. This generic structure is standardized and integrated in the various hardware devices. There are no single solutions. Rather, the researchers integrate the different technologies in a dynamically networked overall system. The various assistance systems are tested in example application scenarios.
Ich möchte Nachrichten sehen.
In the living room, house technology and entertainment media are controlled naturally and completely intuitively.
Heute Abend den Krimi aufnehmen.
Welcher Krimi soll aufgezeichnet werden? Das Geheimnis auf Sat 1 oder Tatort auf ARD oder der Ermittler auf ZDF?
Den Tatort aufnehmen.
A microphone array enables free speech input. The command is analyzed, the parameters are evaluated, taking the habits of the user into account. When, what, and with what. The system recognizes the goals of the user and sends the corresponding instructions to the video recorder. The user promptly receives a response.
Okay, Tatort auf ARD wird aufgenommen.
In addition, the assistance system supports the user in everyday life.
Der Film auf RTL fängt gleich an.
Auf RTL umschalten.
Gesture recognition has also already been realized by the researchers.
Einschalten.
In a driving simulator, an assistance system helps select music. In order to keep the driver's attention focused on traffic, the entertainment unit is operated with natural speech.
Ich möchte Herbert Grönemeyer hören.
With the help of the standardized EMBASSI protocol, the speech input is analyzed and the music player is controlled. The vehicle receives traffic reports. The disruption warning assistant evaluates this information. In case of danger, the system chooses an appropriate strategy for warning the driver.
Achtung! Unfall in 1000 Metern.
The system warns the driver of the traffic disruption in a multimedia way by using various output channels. The warning strategy depends not only on the type of disruption, but also on the preferences of the driver. Another assistance system registers the orientation of the driver's head. The level of attention is interrupted, and the driver is warned if he looks away from the road for too long.
Achtung! Ihr Abstand zum vorausfahrenden Fahrzeug ist zu gering.
Automatic braking can also be realized. The acceptance of these new technologies will be evaluated continually in the context of EMBASSI. For the area of public terminal systems, special demands on interaction are being examined. Handicapped persons, in particular, often have difficulty using public terminals. The example used here is a typical automatic teller machine. Thanks to the components developed in the EMBASSI project, personal access can now be realized. For this, each user has a personal input device. This electronic assistant is adapted individually to the user's special needs. A wireless connection then enables the exchange of information with the automatic teller machine. As a logical expansion to the personal input device, the EMBASSI project partners are currently developing further input and output modules. In this example, simple operation is realized by means of a keyboard and a touch screen. Even the most severely handicapped persons can create entire texts with just a few finger movements. Another device enables the operation of complex programs with a single key. Even demanding computer programs can then be operated easily. For the blind, the so-called Braille pad was also developed specially by EMBASSI. The three application fields described are evidence of the applicability of EMBASSI in the everyday life of the private user. The field ergonomics, however, provides the EMBASSI developer himself with methods, tools, and information. The overall support of the system developing process is necessary to meet the multiple demands on the ergonomic design of the described human-technology interface. This is being achieved by consequent usability engineering. Here, the researchers have access to the ProUse software program. This web-based system is being developed by the Ergonomics Project Group. Based on the requirements of the project, measures are developed and knowledge building blocks are selected. Using these specifications, ProUse generates a hypermedia support environment. This environment provides the team with the necessary information, the approaches to be taken, and existing empirical knowledge. New knowledge is added to the system and can be used for future projects. Another project team is developing the software tool known as Guidance for Developing Assistance, or Guideas for short. Guideas uses various modules to support the developers of assistance systems in their work. The requirements analysis explores the characteristics of users, tasks, and situation. The method module helps if there are gaps in the requirements analysis. From all of the characteristics, the assistance proposal module generates design suggestions. The evaluation module then provides methods for evaluating an assistance system or a design. In this way, the EMBASSI project partners are developing the new era of human-technology interaction by mid-2003. The EMBASSI project team consists of employees from industry, small and medium-sized companies, R&D institutes, and universities. EMBASSI is a focus project sponsored by the German Federal Ministry of Education and Research. The consortium is led by Grundig, and the scientific coordination is handled by the Fraunhofer Institute for Computer Graphics in Rostock, Germany.